All right, I wanted to go ahead and do a review with y'all for the kinds of problems that we learned about last week, just to make sure that everybody remembers how to do them. And so what I'm going to do is I'm going to work a type one of these problems, and then after I work it out, pause the video, and you try the second one and see if you can get the correct answer for that. Once you have an answer, press play. I will work the second one and you can check your answer. All right, let's go ahead and get started. All right. All right, bear with me as I try to work the tablet here to do these problems. All right, so for the first type I have here is a mole to mole, and these are our simplest type of problems, and it's just going to consist of the railroad tracks and with the known in it, and then the mole ratio of the known and the unknown. So first of all, let's start off by writing our known and our unknown. So the known for this problem, which states how many moles of sodium will react with water to produce 4.0 moles of hydrogen in the following reaction. So our known is 4.0 moles of hydrogen. And our unknown is moles of sodium. All right, so what we're going to do is go ahead and put our simple railroad track, which is going to say 4.0 moles of hydrogen. And the next thing we're going to do is put that mole ratio. Now, don't forget our numbers for our mole ratio come from the balanced equation, comes from the coefficients in that balanced equation. So here at the bottom, we're going to put 1 mole of hydrogen. And then up at the top, we're going to put 2 moles of sodium. Then make sure you pull out your calculators, you do a little bit of plug and chug, and you should get an answer of 8.0 moles of sodium. Okay, and once again, my answer has 2 sig figs. Why? Because our known has 2 sig figs. I have my units of moles and also the name of the unknown compound, which is sodium. And don't forget to box your answer. All right, so now that you've seen that one, go ahead and pause the video and you try to work this problem, and once you have it done, press play and see if we have the same answer. Okay, so for number 2, let's try that again. Our known is 5.0 moles of hydrogen, and we are going to solve for our unknown is moles of ammonia. So we are going to put down our railroad track, which is going to have 5.0 moles of hydrogen. And our mole ratio goes next, and we will have from the balanced reaction 3 moles of hydrogen at the bottom and the 2 moles of ammonia up at the top. Once again, you use your calculator, do a little bit of plug and chug, and you get 3.333, that run on 3. And using proper sig figs, you should have a final answer of 3.3 moles of ammonia. And box. All right, let's keep going. The other type of problem that we learned last week was problem type 2, which was mole to mass. Now, remember, for this one, what makes this different from the first problem type is now we have to also calculate the molar mass of the unknown. Okay, so you're going to calculate the molar mass of the unknown. So let me see if I can just get a little bit more space. Okay, and then let's go ahead and once again write our knowns and our unknowns. Okay, let's work this problem here. So for potassium chlorate is sometimes used in the laboratory to generate oxygen. Here is the reaction, and the question is, what mass of potassium chlorate do you need to produce 0.50 moles of oxygen? So our known is 0.50 moles of oxygen. And our unknown, what we're trying to solve for, is the mass, so in grams, of potassium. All right, let's put our 3 there. And let's go ahead and solve for the molar mass of potassium chlorate. So we have potassium, we have chlorine, and we have oxygen. We have 1 potassium in the atom, in the molecule, and 1 chlorine and 3 oxygens. Don't forget, have your periodic table out so you can look up these masses. So potassium is 39.10. Chlorine is 35.45. And oxygen is 16.00. And that's going to stay the 39.10. This is going to stay the 35.45. And then 3 times 16 is 48.00. And when we add these up, we get 122.55 grams per mole. All right, so once again, let's put in down some railroad tracks, and we're going to start off by writing our known. So we have 0.5 moles of O2. And then the next thing we're going to do is write our mole ratio. Because remember, it's the mole ratio that's going to allow us to go from the oxygen to the potassium chlorate. So from our balanced reaction, we see that for every 3 moles of oxygen that's produced, we need to use 2 moles of potassium chlorate. All right, now we can put in our molar mass. So I'm going to put 1 mole of potassium chlorate at the bottom. And I'm going to put the 122.55 grams of potassium chlorate. And once again, we're going to plug and chug, and you're going to come up with on your calculator an answer of 40.85. Now, we got to put this in proper sig figs. So that's going to give you an answer of 41 grams of potassium chlorate. All right, so why don't you go ahead, pause, and try out this next one. And once you have an answer, press play again and see if you and I have the same thing. All right, so for this next problem, our known is 3.25 moles of phosphorus, and our unknown is mass of oxygen. So once again, we need to write the molar mass of oxygen. And so oxygen is going to be, and remember you have two of them, so it's going to be 2 times 16.00, which will give you 32.00 grams per mole. All right, now let's go back and put our known and our mole ratio and our molar mass into our problem. So 3.25 moles of phosphorus, and then we'll use our mole ratio. We have 4 moles of phosphorus and 5 moles of oxygen. And now we can put in our molar mass. So 1 mole of oxygen, and we have 32.00 grams of oxygen for every 1 mole. Once again, plug and chug, and you should have gotten an answer of 520. Now remember, because of sig figs, this zero needs to be significant. So we can do that by either just adding a decimal right there, or you could have written it as 5.20 times 10 to the second. And once again, don't forget your units, grams, and the name of your compound, oxygen. All right, and that should help you refresh your memory on how to do problem type 1, which are multiple problems, and require just a mole ratio, and to do problem type 2, which then requires not just your mole to mole ratio, but also the molar mass of the unknown. I hope that helps. If you have any questions, please feel free to email me or Skype me.